Hi. The purpose of this video is to finish the notes that we started. It's notes number 11, so it's called Use Equations to Solve Word Problems. In class, we were able to finish examples 1 and 2, and we are going to go over example 3 in this video. So I'll start with that. So let's flip to the next page. Example 3 is on the next page. I also will go over the exercises. I will at least start the exercises. I won't finish the problems for you, but I'll at least start it so you know how to set up the equations. Okay, so let's get started. So in example 3, it says Marv earns $9 per hour at his job. On Thursday, he worked a certain number of hours and spends $6 for lunch. If Marv earned $57 Thursday, after paying for lunch, how many hours did Marv work? So we're looking to follow the process that was given to us on the first page. So I'm first going to go back and just show you what that looks like. So all 4 of these steps should be demonstrated in example 3, but also in your exercises. So for every single problem, I'm expecting you to define your variable. I'm expecting you to write an equation. I'm expecting you to solve the equation. And then lastly, step 4, I'm also expecting that you write a sentence to explain what your answer means in context to the problem. So with that in mind, I'm going to be demonstrating all 4 steps in example 3. So this first step is defining your variable. Well, in our question, at the very bottom, they ask, how many hours did Marv work? That's an unknown number, and that's what they're asking us to solve. So that's the variable that I will be using. So I'm going to let H equal the number of hours worked. So Marv went to work, and we're trying to figure out how many hours that was. So that's my first step. My second step is the challenging part, and that is actually setting up our equation. So I'm going to highlight some things to help us identify the important parts of this description. So first it says Marv earns $9 per hour. So that means that if he works 1 hour, Marv will earn $9. If he works 2 hours, he's going to add another $9 to his paycheck. And he'll continue to add $9 because it's something that he's earned. So he'll continue to add $9 to his paycheck until he's done with work, right? Well, it says on Thursday he worked a certain number of hours, and that's what we're trying to figure out, right? They worded it that way because they didn't tell us how many hours he's worked. That's what we're trying to find. But we also know that he spent $6 on lunch. So that word spent means that he had to take some money out of his wallet and pay for his lunch. He had to pay $6. So that's money that he lost. That's money that he spent. And then it says Marv earned a total of $57 Thursday after he paid for lunch. So meaning $57 is what he kept at the end of the day, after he worked and after he'd already paid for his lunch. So that means that the lunch money was already taken out of that paycheck. So our total, I had mentioned in class, I always like to start with what's my end result, what's my outcome, what's my goal, what's my total. And it depends really on the context of the problem. But here, my total is 57 because that's the amount of money that Marv was able to take home at the end of the day. So my equation is going to be equal to 57. And then it says, again, he earned $9 per hour. So we have 9H, so we're going to work our way backwards. So how did he calculate that money? How did he get that 57? Well, he worked he got $9 per hour. So I have to multiply 9 times H because we kept adding 9, but we don't know how many times we added 9. That's what we're solving for. Now that word spent means that he took that money out. He subtracted that money from what he'd already earned. So we have to subtract 6 from the money that he earned. So our equation is 9 times h minus 6 is equal to 57. I just want to point out, and I mentioned this in class, but I'll say it again, in your notes on the right-hand side, I have keywords to help you figure out what words are associated with certain operations. So, for example, the word cost, the word spent, I know those are synonyms, right? That represents oftentimes it represents a subtraction problem. So that's why we subtracted 6. Now, I'm not saying that this is perfect. There are certainly circumstances where it's not true, but when you're working on your exercises and you're sort of struggling with, well, what does this word mean? Or how can I apply this word to an equation, looking at some of these words, looking at this key might help you. So I have the equation. That's step 2. Step 3, now I need to actually solve for h. So I have to show my work. We learned that when you are solving an equation, you're using PEMDAS and you are working backwards. So in step 1, anytime you're asked to solve, the first step should be, do I add or do I subtract first? So that's the first step. And then the second step would be multiply or divide. So in this case, I'm going to highlight this part. I'm subtracting 6. I have to get rid of my constant first. So I need to use the inverse operation, which means that I'm going to add 6. Subtraction and addition are inverse operations, which means they cancel each other out. And we want that to happen because we're trying to get h by itself. So negative 6 plus 6, those cancel out. So that's gone. And my new problem becomes 9 times h, which is equal to 63. So 57 plus 6 is equal to 63. So that's how I got that number. All right, that's step 1. And then step 2, when we're solving an equation, is either multiplication or division. So in this case, we're trying to get rid of the number 9. So I need to undo multiplication. So I'm going to divide both sides by 9 to get rid of the 9. So 9 divided by 9, that's 1. So that's why they're able to cancel out. So I have 1h is equal to 7. So 63 divided by 9 is equal to 7. So I've solved the equation. I've shown my work. The last step is writing a sentence that goes full circle. So in class, I had said, you should be able to, oops, sorry, I wanted a highlighter for that. You should be able to use a complete sentence that would be an appropriate response to the question. So if I ask, how many hours did Marv work? Your answer on your paper, that's written on your paper, should be a complete sentence that answers that question. So we know, based on our solution here, that Marv worked 7 hours, and that's the sentence that I'm going to write. Marv worked for 7 hours. So that concludes my example. So the rest of class is going to be spent working on the exercises. So I think it's really important that you try to attempt these questions on your own. And then I would like you to use this video to help you check your answers. So let's start with the first exercise on the next page. So what I'd like you to do, as I said, is just pause the video and read through this exercise. And I'm going to have you do this with each problem. So pause the video and just read through the question and see if you can set up the equation on your own. Then, once you are done and you've attempted the problem, then you can push play and you can copy down the equation that I have. Now, for these exercises, I'm not going to show you how to solve, or I'm not going to show you the final answer. Instead, I'm going to focus on defining the variable and writing the equation. So that's really what the remaining part of this video is going to be. So let's get started. So pause the video if you haven't already done it, because I'm about to go over exercise 1. So hopefully at this point you have attempted exercise 1. The very first thing you need to do is define your variable. So our variable is, I'm using H, but you can use any letter that you would like. I'm going to say let H equal the number of hours. So they said, and how many hours will the temperature be 32 degrees Fahrenheit? So the number of hours is the unknown number. And the equation, so I do want to explain this part. So they said the temperature is 20 degrees Fahrenheit. It is expected to rise, which means it's going up, at a rate of 4 degrees Fahrenheit every single hour. So that means that we keep adding 4 because the temperature is increasing. We'll keep adding 4 over and over and over again, a certain amount, until we've figured out the number of hours. So again, they're asking, in how many hours will the temperature be 32 degrees Fahrenheit? So I like to start with the total, or the end result, the goal. The wording is always different depending on the problem. In this case, our end result is 32 degrees Fahrenheit because they said how long will it take for us to end up with this temperature. So I know my equation should be equal to 32. All right, and then we want to figure out, well, where did we start? What's the initial value? Where did we start? So we know that the temperature started at 20 degrees Fahrenheit and it kept going up 4 degrees Fahrenheit per hour. So I started with 20 and I added 4 degrees every single hour. So because I kept adding 4 multiple times, but I don't know the number of times we added 4, that's when I would multiply 4 by H. Because again, we're solving for the number of hours that it took to get the temperature up to 32 degrees Fahrenheit. So that's the equation. 4 times H plus 20 is equal to 32. So it's up to you to now solve the equation. So if you don't have the correct equation, please fix it, because of course having a different equation often means that you're going to get a different answer. And of course, don't forget to write a sentence to conclude your thought. So once you're done with that, move on to exercise 2, make an attempt. Pause the video because I will go over exercise 2 next. All right, so hopefully you've attempted exercise 2. If you haven't, again, please pause the video. But if you have attempted it, I'm going to go over writing the equation part. So it says, last baseball season, Ryan had 4 less than twice the number of hits that Marcus had. Ryan had 48 hits. And the question is asking, how many hits did Marcus have last season? Okay, so this is a very wordy problem. So we need to start with our variable. So we know that we're looking for the number of hits that Marcus had. We know Ryan had 48. We don't know how many Marcus had. So we'll call this M. Let M equal the number of hits Marcus had. You want to specify the name in this context because we are talking about 2 different kids. We're talking about Marcus and we're also talking about Ryan. So it's important that because we're solving for what Marcus had, that you include Marcus's name in your definition. So let M equal the number of hits Marcus had last season. All right, so that's the definition of our variable here. And we know that M, that number, is going to be used in our equation. So this question, I must admit, is worded in a very tricky manner. So they said Ryan, we're talking about Ryan here in this sentence, and we're also talking about Ryan in our, I'll call this the purple sentence because I'm underlining this in purple. Okay, so there's 2 different ways that we are describing the number of hits that Ryan has. So first we said Ryan has 4 less. So if we're taking away 4 less than something. So we're subtracting 4 from a number. Ryan had 4 less than twice the number. Twice means that we're multiplying a quantity by 2. We're doubling a quantity. So 4 less than twice the number of hits than Marcus had. So if we compared the number of hits that Ryan and Marcus had, we would say, oh, Ryan must have had more hits because he had almost double. He didn't have quite double, but he had almost double the number of hits that Marcus had. I know that because, again, that word twice means we doubled Marcus's hits, and then we took away 4. So that's one way of describing the number of hits Ryan has. And then in the next sentence, in the purple sentence, it says Ryan had 48 hits. So that's the total that we're going to use in this particular equation. And the reason for that is because both the equation has to have 2 equal parts, right? The left side has to be equal to the right side of the equation. So that means that if Ryan has 48 hits, then the other side of my equation has to be describing how many hits does Ryan have? How is that calculated? So we know that if we doubled what Marcus had, meaning if we multiplied 2 times m, that would be double the number of points. But it says Ryan had a little bit less than that. He had 4 less than what Marcus, 4 less than double what Marcus had, which means we need to take away 4 from that number. So I broke down the equation between the red sentence and the purple sentence to hopefully help you figure out how I was able to set up that equation. So I know that this was tricky, but this equation, the final answer is 2 times m minus 4 is equal to 48. It's quite a mouthful, as I said. And so I'll let you solve the equation. I'm not going to go over that part. So solve the equation, write your sentence, make sure that it makes sense in context of the problem. And so I'll let you finish that. When you're done, I would like you to pause the video and attempt exercise 3. Okay, so welcome back. Hopefully you've attempted exercise 3 on your own. It says, so I'm going to go over this. It says, it costs $10 to enter a petting zoo. So just to go into the zoo, they're going to charge you a $10 fee. It says each cup of food to feed the animals is $2. So that means that if you want to pay for food, 1 cup is $2. And if you want more cups, they're going to keep charging you another $2. And that's a price that they'll keep adding $2 over and over and over again until you are not interested in paying anymore. Okay, so it says if you have $14 to spend, how many cups of food can you buy? So we're going to start with our variable. So we're going to say let C equal the number of cups of food that you can buy. All right, so let's then identify our total. So in this case, the total cost, the total amount of money that we can spend is $14. They said, if you have $14, how many cups? All right, so that means my equation is going to be equal to 14. And then from there, you have to figure out, okay, well, if my cost is 14, what am I paying for so that it adds up to $14? So again, let's start with the fact that our entrance, when you walk into the zoo, boom, you're charged an automatic $10. So even if you don't buy food, you still have to pay the $10. So I know that $10 is going to be added to my cost. I also know that one of the things that I will be paying for is the food. So each cup of food is $2, meaning I'm going to keep paying, or I could pay several times, pay $2 several times. They didn't tell us how many times, so that's why we have to multiply. So we're going to say 2 times C, because we're adding the $2 fee multiple times. So 2 times C plus 10 is equal to 14. So that cost, that equation is going to allow us to calculate the number of cups of food that you can buy. So again, the final equation is 2 times C plus 10 equals 14. So take a moment, solve that equation, write a full sentence, and then you can move on to exercise 4. All right, so if you haven't already done so, please pause the video and attempt exercise 4 on your own. If you have attempted exercise 4, just stick with me and we'll go over this question. So in our description for exercise 4, it says a rental car company charges $30 a day plus an additional 5 pennies per mile. So it says if the Boggs family paid $49.75 for their rental car, how many miles did they travel? So the question, the unknown number, is going to be our variable. So in this case, we're going to say let m equal the number of miles traveled. Okay, so then in our equation, we'll try to figure out like, okay, what's our total? What's our end result? So in this case, our total is $49.75 because that's what the total cost ended up being after the trip. So we're going to say this equals $49.75, and then we just have to figure out, okay, well, how is that cost calculated, right? So right from the get-go, they say the company is going to automatically charge you $30. So even if you rent the car and you don't take it anywhere, they automatically charge you $30. So that gets added to your cost. So you have plus 30. But you're also adding an additional fee, right? Because they will charge you 5 pennies for every single mile that you drive. And we don't know how many times, they didn't tell us the number of miles, so we don't know how many times we're adding 5 pennies. We just know that we're adding 5 cents for every single mile per mile that is driven. So I'm going to have to write that as 0.05 times m. And again, we're multiplying because we're adding this number, but we don't know how many times we're adding this number. So that's the multiplication part. So the final equation is 0.05 m plus 30 is equal to 49.75. So you know the drill, solve the equation, and write a sentence to conclude your answer. I'm going to move on to exercise 5. Okay, so if you haven't already done so, pause the video, attempt exercise 5 on your own. And let's get started. So it says Reggie delivered 8 more than 4 times the number of papers that Sally delivered. So we're talking about Reggie. So Reggie delivered 8 more than 4 times the number of papers Sally delivered. So he delivered a lot more papers than Sally. So it says Reggie, so we're still talking about Reggie. Reggie delivered 156 papers. And they want to know how many papers did Sally deliver. All right, so this is, again, really strange wording. So I'm going to break this up between 2 different sentences, just like I did before. So in the first sentence, we're talking about Reggie. And they said, Reggie delivered 8 more. So that means he added 8. 8 more than 4 times the number of papers that Sally had. So basically, if we knew how much Sally had, so we'll call that 4x. If we have 4 times the number that Sally has, that means we multiplied Sally's paper deliveries by 4. So that's the first sentence. The second sentence then says, Reggie has delivered 156 papers. So both of those sentences, the first sentence and the second sentence, are both describing how many papers Reggie delivered. And that'll be important to recognize because, again, when you're writing an equation, you want to make sure that both sides of the equation are describing the same thing, that they're equal. Okay, so we talked about the wording here, so now let's define our variable. So we're going to say let x equal the number of papers delivered by Sally. Okay, so then now we want to look at the total. So I'm going to color code this because, again, this equation is split up between two different descriptions here. So we know that Reggie delivered 156 papers total. So my equation is equal to 156. I also know that this description in the red sentence that I have here, this first sentence, this is also describing Reggie, okay? The number of papers that Reggie passed out. So we already figured out that 4 times the number of papers that Sally delivered means that we are multiplying 4 times x. And again, x represents the number of papers Sally delivered. So 4 times x, but Reggie delivered even more than that. He went above and beyond because it says Reggie delivered 8 more than 4 times the number of papers delivered. So 8 more means we added 8 to our product. So our final equation is 4 times x plus 8, which is equal to 156. So solve the equation and then write a complete sentence to finish that thought. And I will move on to exercise 6. All right, so I went too far, sorry. Exercise 6. So if you haven't done so, pause the video, make an attempt on your own, and then when you're ready, push play. Welcome back. So for exercise 6, it says an employee at Drive Around Incorporated is reimbursed. The word reimbursed means they've paid for something and they get that money back. So in this case, it sounds like this this employee paid for the car himself, but the company said, hey, we will pay you back. We're going to give you the money back. So whatever you spent, we're going to give you that money back. So this employee was reimbursed 30 cents per mile, plus an additional $15 each time she takes her car to a meeting. So it says Leanna was reimbursed a total of $52.50 after her last meeting. So they're only, in this case, describing one trip because they said after her last meeting. That is a singular word. So how many miles did Leanna drive? So we're looking for miles here. So let M equal the number of miles. And now let's set up our equation. So we know that the total amount of money that Leanna got back. So Leanna paid this money. Leanna paid $52.50 from her pocket. So I know the total is $52.50 and the company reimbursed her, which means she got that money back. Her boss probably said, here's $52.50. Okay, so the total is $52.50. How was that calculated? So it says miles plus, so she was they added $15. I'm going to start with that. It says if she has to go to a meeting, they're basically automatically paying her $15. And she was also paid 30 cents for every single mile. Now, we don't know how many miles she drove. So meaning she added the company paid her 30 cents for every single mile that she went. So 30 cents was added multiple times. We just don't know how many times. So 30 cents is being multiplied by M. That's a product to represent that we added that number over and over and over again. And in this case, after adding up the 30 cents for every mile and the $15 extra that she got for driving to her job, the total, as I said, that she got back was $52.50. So your final equation for exercise 6 is 30 cents, so 0.30 M plus 15 is equal to $52.50. I know this was a really long video, but there was a lot of problems here, and I wanted to make sure that we at least had the correct setup. I know that you guys are really good at solving equations and showing your work, so that part I know was not as much of an issue. So good luck. I just want to also mention that the answer key to the notes number 11 are also posted on Schoology. So once you're done with the videos and you've attempted all of these all of these exercises, it would be good for you to go onto Schoology and then check the answer key, because I have a picture of every single page. So it goes through not only the explanations that I have, but I also have the work. So in this video, I only went over the definition of the variables and writing the equations. I didn't go into solving or actually telling you what the final answer was. Whereas on my answer key, all of that is provided for you. Now it's a picture, it's not, there isn't really like an explanation, but at least that way you'll know whether or not your calculations are correct and if your work is correct. So definitely take advantage of those resources. All right, so I hope that this was helpful. And as always, if there's questions that come up, please just let me know. You can email me or ask your teachers. As you know, Mrs. Miller and Mrs. Curler are really great resources, so certainly take advantage of them while I am out. All right, well, thank you again for watching, and I guess I'll talk to you later. Bye.